Okay, good day everyone. So we are here for another topic for hydraulics and that will be water hammer. So I am Engineer Moscosa and will be discussing this topic. So again, so what is water hammer? No, paano ba to siya? Ano ba yan siya? Paano ba to nangyayari? So water hammer is a resulting shock caused by a sudden decrease in velocity of fluid. Okay, so it is a pressure surge or a wave resulting when a fluid in motion is forced to stop or change the velocity. A water hammer commonly occurs when a valve closes suddenly at the end of a pipeline system and a pressure wave propagates in the pipe. It is called hydraulic shock. So ang water hammer natin is also called as your shock wave. So sulat natin. It is also called as shock wave. No? It is called a shock wave transmitted from fluids containing a piping system. So ang occurrence daw or occurrence niya in fluid in motion is suddenly forced to stop the fluid from moving. No? So when a water is moving through a pipe, it has acquired to be a momentum. Ibig sabihin, when there is a flow of water sa ating pipe, meron tayong momentum na kino-consider like itong nasa figure number 2 natin. Nakikita natin na open yung valve, therefore there is a flow of water, no? So, if you suddenly stop the flow of water by closing lang yung valve natin, therefore, no, yung momentum natin has nowhere to go. So, kung bigla lang nating sinara yung valve natin, ibig sabihin yung flow of water natin is nadi-disturb. No? Since water is incompressible, it can slam all through walls. No, hindi natin alam, 'di ba? You have your momentum, that you have your flow of water kasi gusto lahat ng tubig is lumabas. Kasi 'di ba kung saan yung may daluyan, dumadaan talaga yung tubig. But when it suddenly stops or bigla niyo na lang sinarado or kinlose yung inyong valve, ibig sabihin yung tubig na gustong lumabas, mababangga siya mismo sa valve and then babalik siya sa pinanggalingan niya. Wala siyang mag-bounce back ba? No? Tapos paano ba tayo Tagalog? Tapos masasagopa niya, masasagopa, tama ba yung term? No? Or magko-collide sila nung mga tubig na gusto ring pumasok pa or lumabas pa. So magbabangga sila at magproproduce sila ng shockwave inside our pipes. Okay? So take note that nawala tayo. So take note that itong shockwave na ito or itong water hammer natin is a problem also sa mga pipe natin kasi pwedeng masira yung pipes natin when ang pressure, no? When ang pressure present sa shockwave natin is sobrang lakas. So nakakasira siya ng pipeline system natin. Okay? So I feel Okay, so as you can see no dito sa first diagram natin na ito, water is still, ibig sabihin stable lang yung tubig natin since ang valve natin is closed siya. Wala pang nangyayari. Wala good sa inyong gripo, close pa inyong gripo, therefore walang tubig na lumalabas. Pero once that you turn on or binuksan nyo yung tubig ninyo, ibig sabihin the flow or of water is lumalabas siya sa gripo ninyo or sa faucet ninyo at nagpo-produce ng tubig. So ibig sabihin nagfo-flow siya. No, it has a momentum. But kapag natapos mo nang ginamit yung tubig ninyo, when you close or when you off, ano ba dapat? Off or close? Off siguro, off the faucet or sinarado yung faucet ninyo, yung tubig na gustong lumabas, no, hindi siya makakalabas kasi sinarado nyo, bababounce back siya, no, dito sa loob at magkakaroon ng disturbed motion sa loob ng inyong valve. Okay? Yan yung tinatawag natin na water hammer or yung shock wave natin. Yun pala, lagay natin dito, shock wave. That is called as your shock wave. Okay, so I have here a video, so kindly watch this one. I don't know if you can hear this, pero ito yung principle ng water hammer kung paano siya nangyayari. Yun, so nakikita nyo na di-disturb yung pipe natin, lumulobo yung pipe natin, no? Kasi when you suddenly close the valve, no, yung mga tubig na gustong lumabas, no, nagba-bounce back sila pabalik sa loob. So nagkakaroon ng pressure sa ating pipe na nagko-cause ng leakage. Yun yung right term pala, yung leakage natin. Okay, so let us continue. So the formulas for our water hammer, meron tayong considered na rigid pipes that when your C is equals to square root of EB over your rho, and you have your non-rigid pipes, which is your C is equals to square root of EB times rho times 1 plus EB over DET, where your P, that would be your pressure or your water pressure, your V, that would be the velocity of water, your EB, that would be the bulk modulus of water. Your rho, that would be your mass density. Yung C, yan yung tinatawag natin na celerity, or that would be the velocity of sound, no? The thickness of the pipe, the diameter of the pipe, and the modulus, no? So ako, nung nag-board exam kami, no, memorize ko tong formula na ito. Like for this one, memorize ko dito is it bulaga pa. No, it bulaga pa. Kasi yung kung ano yung magiging mnemonics niya dito, basta ako, no, mas madali mo talaga memorize yung isang formula, no, kapag meron kang mnemonics. Take note, no, napakarami yung formula na i-memorize, hindi lang dito sa hydraulics, meron pa kayong foundation, or you have your geotech pa, na napakarami pa. So dito, no, that would be it bulaga. Share ko na lang rin sa inyo, no, so baka magamit nyo rin, it bulaga pa. It bulaga. It Bulaga, Dabarkads, over It Bulaga, over It Showtime. Yun na lang. Pakinggan nyo na lang sinasabi ko. No, ang mnemonics ko dito, It Bulaga pa, It Bulaga, Dabarkads, It Showtime. No, It Showtime. Parang ganon. Ganon yung nagiging mnemonics ko nung nagre-review ako. So time of closure, yung time ng pag-close mismo ng valve natin, it can be solved using 2L over C. Your L, that would be your length. Your C, that would be your celerity. So when T is greater than 2L, so this is your formula. P over rho max, 2L over C. So change of in pressure, that would be rho CV lang pa rin. Okay, so you can get also your pressure, no, between if may time tayong binigay. So that can also be given as your time na na-solve natin using the time of closure times the pressure. Sige, para mas maintindihan natin, let us have an example. So you have here the elasticity and dimension of pipe are such that celerity of pressure wave is 970 meters per second. So suppose the pipe has length of 1,600 and a diameter of 1.2 meters, and the initial flow would be 0.85 cubic meters per second. So first question, let us try to determine what is the water hammer pressure for instantaneous valve closure. So letter A, no? Ano ba yung hinahanap natin? That would be your pressure, the water hammer pressure. So you have here, no, yung formula natin for water hammer pressure, that will be rho CV. Since water yung given, no, conclude natin na water yung given, you have your rho as 1,000, your C, which is the velocity of sound, which is your celerity, that would be 970 meters per second. At wala tayo would be your velocity. Okay, but you all know you can get the value of your velocity using your Q is equals to AV, given ang ating Q, given ang ating diameter. So therefore, pwede nyo makuha yung value ng velocity ninyo. So you have 0.85 is equals to pi over 4 times 1.2 squared times the value of your V. Okay, the value of your V, that would be 0.75 meters per second. Pause nyo na lang na para makuha nyo yung value. So having that said, now you can get the pressure. So you have 1,000 times yung celerity natin na 970 times your velocity na 0.75. Therefore, the value of your P, that would be, yes, that would be 731.25 kPa. Pause niya ha para makasolve kayo ng value. So this is for letter A. So how about for letter B? So letter B natin, how much time should be allowed for the closing of valve to avoid water hammer? So ano daw yung kailangan nating na oras, no? Para maiwasan natin yung shock wave natin. Okay? So let us try to get that one. So pwede natin yan siyang makuha ng time of closure natin para wala kayong shock wave that is in the formula of 2L over C. Okay, so you will be having 2 times yung length natin 1,600 divided by the celerity which is 970. Therefore, your time no to avoid the water hammer that would be equal to 1.23 seconds. So this is your answer for letter C. Ibig sabihin, ina-avoid natin yung water hammer or yung shock wave na ito sa oras ng pagsarado natin ng valve natin. Okay, so for letter C, ano meron dito? Find the appropriate water hammer pressure of the valve if it closes to 4 seconds. So nagbigay siya ng condition na yung valve daw niya is nagsarado siya ng 4 seconds. Okay? So ibig sabihin, no, meron siyang time limit na binigay na yun nga, yung valve natin is magsasarado, no? So yung time natin ay wala tayong pressure or water hammer pressure that is in 1.23 seconds. So if that is the case, no, meron tayong dalawang time na ginamit. Kukunin natin yung ratio niya tapos i-multiply natin doon sa nakuha nating pressure a while ago. Okay, para makukuha natin yung water hammer pressure about this time. So that would be pH is equals to the time na nakuha natin divided by the time condition multiplied by the pressure na nakuha natin kanina. Okay, so that would be 1.23 divided by 4 times your pressure which is 731.25. Okay, ilan kaya ang value niyan? So that would be 225 kVA. Okay? Sana nasusundan. So yan lang yung pressure no na nafi-feel ng ating pipe no na kapag sinarado siya into 4 seconds. So what if yung time of closure natin is greater than sa time na binigay natin no para makuha natin yung pressure. Ibig sabihin kapag ganito yung nangyari sa situation natin, maximum pressure na yung nasa-solve natin. Maximum pressure. So when we're in this case, hindi pa natin siya magko-consider as maximum since yung time of closure natin na na-solve kanina is great or is smaller than sa time na binigay ng condition. Okay? Sana naintindihan yon. Let us have another example. So you have here, a valve is suddenly closed in 200 mm diameter pipe. The increase in pressure is 700 kPa, assuming that the pipe is rigid and bulk modulus of water is 2.07 times 10 raised to 9 Newton per meter squared. So hahanapin natin yung celerity, yung discharge, at yung water hammer pressure. Okay, so let us try to solve for letter A. So since rigid to, ano yung formula natin sa celerity? That would be it bulaga pa. Na? That would be the square root of EB divided by your rho. Okay, so you will have direct sub lang. Ito yung pinakamadali na topic siguro, no? Direct sub lang tayo ng formula 10 raised to 9 divided by 1,000. So your celerity is how much? That would be 1,438.75 meters per second. Yan na. Yan agad yung magiging answer for letter A. So how about for letter B? Okay, so we will try to figure it out kung ano yung magiging value ng discharge natin. Okay, so your discharge that can be solved because Q is equals to AV. Ang area, wala tayong problema kasi diameter is given. Yung velocity ang ipoproblema natin. Okay, so since there is pressure given sa formula ay sa question, there is a celerity, therefore pwede nating makuha yung ating velocity. It is in terms of your pressure. So that is pressure is equals to rho times your celerity times your velocity. Where your pressure, that would be equal to 700. Ang unit weight density, that would be 1,000. Ang celerity, that would be 1,438.75 0.75 times your velocity. Okay, try to solve for the velocity. Your velocity, that would be equal to 0.486 meters. So can you double check the values, no? Because I am not certain also. Paki-double check niyan. So therefore, pwede nyo na makuha yung maximum discharge natin. Okay? Can you take disregard of the word maximum? Huwag tayong gumamit ng maximum, just the discharge only. Huwag tayong gamit ng maximum. Okay? Okay. Tama pala yun kasi meron pa tayong increase in pressure. Tama yan. We'll consider a maximum discharge. So sige, kunin natin yung discharge ninyo. So that to be Q is equals to pi over 4 times 0.2 squared times your velocity, which is 0.486. Therefore, your discharge, how much is your discharge? That would be 0.0153 cubic meters per second. That is correct. So for letter C, no, if the length is 800 meters long, what is compute the water hammer pressure if the time of closure is T is equals to 3 seconds. That would be capital T dapat kasi yan yung sa situation na binigay. So let us try to compute what is the time of closure, no, based sa ating formula base. So ano yung oras na pwede siyang magsarado na wala tayong water hammer pressure? So that would be 2 times 800 divided by the celerity, which is 1438.75. So ilan ito? That is 1.112 seconds. Tama. Therefore, your time of closure is lesser than the time given by the situation. Therefore, kukunin natin yung, therefore, it is not yet the maximum pressure. Okay? So, maximum water pressure sa time na 3 seconds. Okay? So, kukunin natin yung pressure na present dyan. So, that would be 1.112 divided by the given time ng pag-close niya times the pressure given, which is 700 kPa. So that would be equal to 259.47 kPa. Okay, I hope naintindihan yan. Okay? So let us go to your last example for your water hammer. So water hammer or water from a reservoir flowing through a non-rigid na naman tayo, non-rigid 600 mm diameter pipe with a velocity of 2.5 meters per second is completely stopped by a closure of a valve situated 1,050 meters from the reservoir. So assume that the pressure increased at a uniform rate and that there is no damping of pressure wave. The pipe has a thickness of 18 mm. Bulk modulus of steel is 200,000 MPa. So let us compute the velocity of sound in water. That would be your celerity. Determine the maximum pressure if it takes 1 second and determine the maximum rise of pressure when it takes place in time. When it takes place, hindi ko mabasa yung ano kasi natabunan. When it, ano ba yan? When it takes place after 5 seconds. So, non-rigid na naman tayo. So, aalamin doon natin yung celerity or yung volume of sounds natin. So, since non-rigid tayo, so therefore, gagamitin nyo yung formula ninyo, no, for celerity, yung napakahaba, yung itbulaga pa, itbulaga, the barkads, it's showtime. Yun yung gagamitin ninyo na formula. So, that would be EB, itbulaga pa, Itbulaga the workouts, it show time. Okay, so you will have the square root of the value of your EB, which is your modulus of water. Saan ba yun? Bulk modulus of water. Oh, hindi ko nalagay. Sige, the bulk modulus of water, that would be considered as 2060. Okay, that would be considered as 2060 MPa. So that would be times 10 raised to 6, no? If you convert natin siya. So that would be 2060 times 10 raised to 6. So take note of your MPa, GPa, your KPa. Take note of that, ha? Kasi kinakailangan yan to convert the values. Divided by the water density. So that would be 1,001 plus yung EB natin, that would be considered as 2,060. Kino-convert ko na siya agad, guys, ha? So times the thickness or times the diameter. Sana yung diameter natin, which is 600, okay, mm, divided by the bulk modulus of steel, that would be 200,000. Okay, that would be 200,000. This is MPa, 200,000 MPa times the thickness, which is 18 mm. So ito hindi ko na siya kinonvert since makaka-cancel din naman yung ating unit. So mm is cancelled, MPa is also cancelled. So your celerity is, yes, that would be 1238 1238.35 meters per second. So that is our answer for letter A. So for letter B, let us determine the maximum pH max, no, when your T is equals to, that would be capital T dapat. Excuse me. When your T daw or the time of closure is equals to 1 second. Okay, so hanapin muna natin yung time of closure natin, no, having a formula of 2L over C. So you have 2 times 1,050 divided by 1238.35. So ilan yung time natin? That would be 1.696 seconds. 696 seconds. So as you can see, no, the time of closure natin is greater than the time presented sa ating situation. Therefore, you can conclude that your pressure is a maximum. Yun yung sinasabi ko kanina. Okay? Therefore, your pH max or your pressure of your water hammer is equals to rho CV. Okay, so that would be 1,000 times your celerity, which is 1238.35 times your velocity. Ano yung velocity na celerity times your velocity, which is given sa problem, which is 2.5 meters per second squared. So that would be 2.5. Okay, therefore your pH max is how much? Convert na lang daan sa KPa. Okay, so that would be 3,095.9 kPa. So therefore, we can conclude that no? So sabi niya, when the time of closure daw is 1 second, nagkakaroon ng maximum rise in pressure. And that would be 3,095.9. Okay? So aalamin naman natin ngayon yung time of, or I mean yung maximum pressure if the time of closure, no, another situation, another condition, when your T is equals to 5 seconds. Okay? So no need to solve for the time of closure na kasi nasolve na natin to as 1.696 seconds. So matik na, diretso na tayo sa pressure. So that would be, okay, so that would be 1.696 divided by 5 times yung pressure na nakuha natin kanina, no, which is the maximum pressure as well. So that would be 3,095.9. Okay, so that would be pH is equals to 1,050 kPa. So as you can see na yung letter B is hindi natin siya sinolve the way na sinolve natin siya sa letter C. Take note na wala tayong pinagbabasihan ng pressure para masabi natin siya na maximum sa point B. Okay? Wala tayong pressure na pinagbabasihan para masabi natin siyang maximum. So kaya nagkaroon tayo ng formula na rho CV. Unlike no sa ating ang tawag yan? Ating point C na meron tayong pressure na pinagbabasihan which is yung 3,095.9 kPa. Okay, so that is our presentation for this afternoon. I hope you learned something. No, so if you have any clarification or questions, so you may ask me or sa GC na lang agad para tuloy-tuloy yung pagsagot natin. So I think this will be included sa inyong quiz on the next meeting. So thank you and God bless everyone.